Now that you know what SIFT looks like, a brief tutorial on how to use the probe density diagram. So you can open data, control open, and search for the data. This is a slow process if you haven't, it can be a slow process, so it's a lot easier sometimes to open it from the cache if the data had been loaded already. So I brought up the open data from cache window. I'll select all of them doing the shift click. And then they will load a lot more quickly than they would be if they were loading initially. So when it initially comes up, you'll notice the gray bar there is showing you which band is being displayed. That's also shown in the bottom right. We haven't used the probe yet, but if you right-click on the probe, you do get a probe of all the different channels that are loaded at that particular point. So you'll see the reflectances and the brightness temperatures for the visible near-infrared and infrared channels. You can pop that window out, and so you can see you can see the probe values everywhere at once. Let me expand this. I'm having trouble moving the image, not the probe. Having trouble grabbing it here, but so you can see all 16 channels here, and right now again we're looking at band 1. That's the one that is highlighted in the probe, and then if you use the arrow keys, you can cycle through the different channels, so you can quickly compare adjacent channels, or just quickly see what the different channels look like using just the up and down keys to change bands. You can also go to the view and click next band there. That's kind of cumbersome, so the shortcut is a lot easier to use for this particular feature. So we're going to right click now on the there's some obvious sun glint here. We'll click on, do a probe in the sun glint. You'll see all the values change. You're getting a lot more reflectance, and you get much higher brightness temperatures with the 3.9 micron. Again, we can, as we move the probe around, look how quickly everything changes. So the probe really gives you a very quick look at all values at once. And when you change the probe location by a right click, it changes very quickly. Now you can pop that back into, it back into where it started from. Now we're going to choose a region. We're doing this by doing right clicks after clicking on a region, and you'll notice we're defining this ice cloud feature. And when you close the polygon, the purple region occurs, and we can now look at this bar graph that shows you, initially we're looking at band 1, that's the default that comes up, even though we're looking at band 5 on the screen, but it's easy to change it to band 5. I'll just do that right now, and you'll notice that well, let's pop this out so double click on it and it pops out, and then you can resize it. And when we're looking at the reflectance values from band 5, you see they're pretty small. They get up to maybe a quarter, maybe 0.3 at the very most. And if we change it to band 4, the reflectance values are much larger because we're looking at an ice cloud feature. We can also compare bands 4 and bands 5 in this density diagram. So the band 4 is uniformly larger. The reflectance of band 4 is almost always larger than the band 5. So band 4 is on the x-axis, band 5 is on the y-axis. There is an x equals y line that I'm highlighting here, and notice how that band 4 is almost always to the right of it. So you can see that the band 4 reflectance is always greater. Now we're going to change this and look at water vapor. So we're looking at the band 8 and band 9, band 8 and band 10. And I'm going to change what we're looking at in the scene here. We're going backwards. So this is band 16, 15, and eventually we'll get to the water vapor. So we're now looking at band 8, 9, 10, 9, 8, 9, 10, back looking at band 8, and you'll notice that band 10 is always warmer than band 8, except when it's very cold. If you're at the very top of a thunderstorm, for example, you're not going to have a big difference between the band 8 and band 10 temperatures. Pop this back in. Of course, the data is still there. Now you can also make RGBs. So this is a relatively new feature. If you go to Layer and Create Composites, so we're actually going to be creating another layer that we'll see in the layer list, and I'll show you that. I'll show you that later. I'm just kind of picking random values right now, choosing bands 8, 5, and 4, and then we're going to create this RGB, and then you can explain how. Let me hit escape to get rid of that purple diagram, that purple polygon. So you should be able to use your knowledge of the different channels to decide why which colors are where. Let me change this now to bands 3, 4, and 5. I'm putting band 4 in the green. I think that's done a lot because the band 4 for AHI is the veggie band. This would be band 3 on ABI. And that means because it's so reflective, because land features are so reflective in the veggie band, the 0.86. When you put in an RGB, you get this nice green tint to an island. So I've turned off the borders using the B key, so you can really see very nicely what the islands look like. Now I'm changing this to changing it to 8, 9, and 10 now, just to get rid of the features. And one of the things that happens here that you see is the values, the default values on those sliders are too hot and too cold for a water vapor channel. So I'm going to adjust them. You can adjust them using the slider, or you could just type in the values into those boxes if you wanted exact values. And this is an RGB that you might create because you can use it to distinguish between upper level and lower level features because of the difference in the weighting functions for the various RGBs for the water vapor channel. So here we have that new layer that's been created, so we can toggle between that layer, for example, in a visible image, so turning the layer on and off the visibility. So these are just some of the few things that you can do with SIFT. I hope you explore it and figure out some more.